These are solutions for the study guide for Chapter 8, Section 1, Chapter 8, Section 2. So let's take a look at our first problem here. It says the volume of a solid round your answer. Here's find the volume of the solid round your answer to the nearest tenth. And so the solid in this case is a cylinder. And so our volume formula goes this way. Volume equals pi r squared, which is the area of the base, times by the height. And so we're just going to substitute our numbers in here. Problem is that we don't have the radius. We have the diameter in this problem. So if we have the diameter, which goes from end of the circle or curve of the circle to the curve of the circle through the center, we need to find the radius. And so the radius is going to end up being half of that diameter. So if the diameter is 10, we're going to divide that by 2, and that's going to give us 5. So that's the number we're going to substitute into our formula. So pi times 5 squared times by 6. So the distance from circle to circle is the height. And so now we go ahead and substitute. We substitute the numbers. Now we're going to go ahead and multiply. 25 times by 6, and 25 by 5 squared is how we got that number. And then 25 times 6 makes 150 pi. Now this is the exact answer, and this is in cubic meters. Now we're going to approximate it by using the calculator here and entering 150 times by, and then I'm going to use the pi symbol here, and these are the numbers I get. So I get 400, and this was 71.23. So I rounded the tenths place because it says to the nearest tenth, and that's going to end up rounding down to 471.2 millimeters cubed. Make sure you have those correct units there, cubic millimeters. So looking at our next problem, here it says we're trying to find the missing dimension of the cylinder. Round your answer to the nearest whole number. So they give us the volume, we're trying to find the height. And so here's our formula again. Volume equals pi r squared h. So what we can do is we can remember, we just substitute our numbers into the formula, and 32 inches is the diameter. So this is another diameter here, so we are not given the radius. So from that, the radius is going to end up equaling the 32 divided by 2, which makes 16 inches. And that's the radius that we're going to end up using. So the volume, the 10,000 pi, equals, and then we've got pi times by 16 squared times h. And so we can do this in stages here. See, if I divide by pi, that will cancel out the pi symbol. So now I'm just left with the 10,000 equals 16 squared. I'm going to do that work, makes 256 h. So 16 squared made 256. So now I'm going to divide by 256, and that'll give me the answer. So let's check out what that is. So we'll clear this. Again, 16 squared, that's how I'm getting that 256. So I get 10,000 divided by, and then 256. And that gives me 39. Let's pull that up once more. 39.06. Alright, so we're supposed to round to the nearest whole number. So we look at the 0, and that does not round that up, it rounds it down. So 39 inches is equal to the height. So moving on to the next problem, it says a water cooler is in the shape of a cylinder with a diameter 2 feet. Okay, so here's what it looks like. The diameter is all the way across again, and that is 2 feet. And then the height of this cylinder is 3 feet. So from the top to the bottom is 3 feet. And so it says about how many gallons of water can the cooler contain, round to the nearest gallon. So let's find out how many gallons it contains, or how many cubic feet it contains. So we're going to use our formula, volume equals pi r squared h, but this is equal to the diameter. And so again, I need to do the radius, or find that radius, which is the diameter. So 2 feet divided by 2 equals 1 foot is the radius. So I substitute the numbers in there. Pi times by 1 squared times 3. So 1 squared is 1 times by 3 is 3 pi. And so to find that volume, I'm going to do 3 times by 3.14. So 3 times, and I'm just going to use the pi button again. So it gives me 9.42. Now I'm going to draw some dots there to symbolize that it goes on forever, because I'm not going to clear that number. I'm just going to leave it in there. But that is in cubic feet. So now I'm going to multiply by the conversion factor, 7.5 gallons per cubic foot. The reason why I put the cubic feet on the bottom is to cancel out the cubic feet. And so then I'll be just left with gallons. So let's take that number, multiply it by 7.5. It gives me 70.68 gallons is what that was. And so they're asking me to round to the nearest gallon. So the 6 is going to round this up. So I'm going to round up 71 gallons. That's what we have there. So looking at the next problem that we'll end up seeing, we're dealing with cones, and the first one is asking us to find the volume. So the volume of a cone is 1/3 the volume of a cylinder. So pi r squared h times by 1/3. And so I'm going to substitute my numbers in there. 1/3 pi times the radius, 6 squared, times by the height, h is 7 in this case. So I take 1/3 of, and then 36 times 7. Well, 1/3 of 36, 3 goes into 36 12 times. So now I have pi times 12 times 7, and 12 times 7 makes 84. It's 84 pi. That's the exact answer. Let's find out what that is, because we need to round to the nearest tenth. So we'll do 84 times by, and then we'll use the pi button again, and that gives us 263.89. 263 and 89 hundredths. So looking at this, I'm supposed to round to the nearest tenth, so the 9 is going to round that up, so it's 263.9, and then these are inches cubed. Again, I'm using the pi button. If you use 3.14, it's going to modify this, probably be 263.8, rounded to the nearest tenth. So the next problem asks us to find the missing dimension. We're supposed to find the height here, and we're given the volume, given the radius, and we're supposed to round to the nearest whole number. So let's write down our formula. 1/3 pi r squared h. We'll substitute the numbers in there. 7,200 equals 1/3 pi times the radius squared. So 15 squared times by h. That's what we're looking for. So the first step I'm going to do is multiply by 3. That's going to cancel out the 3. Do the same thing on this side. So we'll write down 7,200 times by 3 gives us 21,600 equals pi times, and then I can go ahead and take 15 squared as 225 times by h. Let's divide by pi, and so we'll take that number and divide it by pi. I'm using the full pi button, and I get this 6875, and then it continues on. Again, I'm just going to put these dots here symbolizing that that number continued on, and then I'm going to divide by 225 and take that number, divide it by 225, and this is what I get, 30, and that was 0.557. Alright, so we're supposed to round to the nearest whole number, and so that 5 is going to round that up, so we're going to call it 31 yards is equal to the height. So moving on to the next problem, it says sand falls from an hourglass at a rate of 50 cubic millimeters per second. How much time will it take the hourglass to empty? Okay, time is what they want. They don't specify the units of time, so we're going to change it to seconds because they give us the rate in cubic meters per second. So we're supposed to round to the right there it says round to the nearest whole second. So we're going to go ahead and find the volume first. Volume equals 1/3 pi r squared h. substitute our numbers in. Now notice how they give us the entire diameter here, but that's not what we have, what we want. So it looks like the sand is only here, down a little bit lower, so it looks like the radius is 10. So this is extra information. We need this. And so we're going to end up going ahead and just using this information here, 10, so 1/3 times by pi, 10 squared times by 24. And I'll do some work there. I could take 1/3 of 24, so that makes 8. So now I've got pi times by 100, get that by squaring 10, and then times by 8. So it makes 800 pi. And so I'll go ahead and multiply that now. So 800 times by, and I'll use the pi button, gives me this number, 2513, 2,513. These are cubic millimeters. Now I'm going to take that number, 2513.27 and so on. I'm going to take that number and I'm going to multiply it by the rate. And the rate is, and this is per second, 1 second is equivalent to 50 cubic millimeters. So I put the 50 cubic millimeters in the bottom to cancel out the cubic millimeters on top of that number that was 2,513, the volume of the sand in this hourglass. And we're going to multiply, or divide that, our answer then, divide it by the 50. That's going to give us the number of seconds. So it's going to be 50, and this was 0.2. We're supposed to round to the nearest whole seconds, so it's going to just stay 50 seconds. It's going to take the time it takes the hourglass to empty. So moving on to the next problem here, it asks us to find the distance between these 2 points. So we're going to use our distance formula. And the distance formula is basically setting up a triangle. See, we want to find the horizontal distance and the vertical distance, and then we want to find out what this distance is between the 2 points. That's our goal. So the horizontal distance is the subtraction of the x values. Vertical distance, the subtraction of the y components of those ordered pairs, and that's what we're going to be doing. So we're going to do 2 minus 7. Those are the two x values. These two values right here, the x minus x1. We're going to square that answer, because that's what we do with the triangle. Leg squared times leg squared, or leg squared plus leg squared, equals hypotenuse squared. And then take the difference of these two y values, 4 minus 2, quantity squared. So that was y minus y1. So we're taking the square root of that answer, because that's what we do when we're trying to find the hypotenuse. So we get negative 5. Now it's not negative 5 equaling negative 25. It's negative 5 times negative 5, which is going to give us a positive 25. And we get a positive 4, and that makes positive 29. So we should always get positive numbers underneath the radical sign when we're using this formula, and we'll go ahead and approximate this. So I see that the square root of 29 is between these two perfect squares. And so the square root of 25 is 5, the square root of 36 is 6, so that number is a little closer to the 5. So if I was to approximate it, I would say 5, and then it is 4 away from 25. So 4 over, and then the total distance between the two perfect squares is 11. So 5 and 4 11ths, a really good approximation. And this is about 5.4 units. So looking at the next problem, what we need to find out is the measure of this angle. So we have to first know how many angles there are in here. So one way we can do it is to use this formula, n minus 2, which is the number of sides, minus 2 times by 180. If you didn't know that formula, you could always make triangles from a point and then find out how many triangles you can make in here, and you'll be able to make the same number we get when we subtract the number of sides, which is 7, from 2. So that means we can make 5 triangles out of this, and when I make those 5 triangles, multiply them by 180, because each triangle has 180, that would give us 0, 0, and then add a 4, it makes 900 degrees, is the entire is the sum of all the angles in this. So if I take 106, 120, 102, 114, 121, 113, And I add up all of those angles. And all those angles sum to make 676. And I add on the missing angle, x, and then this equals 900. So just subtracting that 676 from both sides in this case gives us our answer of 224 degrees for the value of x. So looking at this last problem, it says you and your friend are standing back to back. You run 3 feet forward and 2 feet to your right. So 3 feet forward and then right 2 feet. So there's 2 feet, 3 feet. And then your friend is back to back. At the same time, your friend runs 4 feet forward. So 4 feet for your friend is going to be out in this direction because you are back to back. And then 3 feet to her right. So 3 feet her right would be in this direction. And so then they throw a snowball, and we want to find out how far did your friend throw the snowball. So we want to find this distance. And so what we're going to do is make a triangle out of this. And so if I go ahead and draw in the triangle that we have, so right here is the triangle we want. So the entire distance here for this is 3 plus 2 for the vertical distance, which is 5. And the horizontal distance is 4 plus 3, which is 7. And so we're going to use those numbers, 5 squared plus 7 squared. And then we're going to take the square root of that answer because that's going to give us our distance squared. So 25 and 49. And those two numbers add to make 74. And then if I wanted to find out what that number is, it's going to be in between the square roots of 64 and 81. So it's in between 8 and 9. And so looking at that number, it's a little bit closer to the 81, just slightly, almost right in the center. So it's going to be 8 and then 64 and 74 are 10 apart, where 81 and 64 are 17 apart. And so if I was to approximate this would be about 8.6, right around that range. So 8.6, and these are in feet. About 8.6 feet would be a good approximation. So those are the types of problems you're going to see on this week's test. Good luck.